Hello everyone, this is ARHAM from Sri Venkateshwara College of Engineering, studying in third semester in the Departments of Computer Science Cybersecurity. Today I'm here with the topic Mathematics for Computer Science stream, that is normal distribution. The contents will be looking to know about normal distribution, that is a closer look on bell curves and statistics. A bell curve or normal distribution is a statistical concept representing the distribution of data. It is named after the shape, that is the bell shape. The majority of data points are concentrated around the mean, with fewer points towards the extremes. The bell curve is defined by the mean, the standard deviation, and the mode also, representing the central tendency and the spread of data. Symmetry and curves, it is symmetrical with equal likelihood of data points occurring on either side of the mean. Bell curves are used in psychology, sociology, economics, natural sciences, and understanding the data distribution. The characteristics of a normal distribution are the mean, median, mode are exactly the same. The distribution is symmetric. About the mean, half the values fall below the mean and half above the mean. The distribution can be described by two values, the mean and the standard deviation. What is normal distribution? It is the probability theory and statistics. The normal distribution, also called as the Gaussian distribution, is most significant continuous probability distribution. Sometimes it is also called a bell curve. A large number of random variables are either nearly or exactly represented by the normal distribution in every physical science and economics. Furthermore, it can be used to approximate other probability distributions. Therefore, supporting the usage of the word normal as in about the one it is mostly used. Here we can see the formula for normal distribution. Y is equal to 1 by sigma root of 2 pi e, where mu here minus x minus mu whole square by 2 sigma square. Mu is mean, sigma is standard deviation, and pi is 3.14, e is the standard value 2.7. Normal distribution is the statistical phenomenon representing the symmetric bell-shaped curve. Most values are located near the mean. Also, a few appear on left and right tails. It follows the empirical rule of 68, 95, 99.7 rule. Here, the mean, median, and mode are equal. The mean and the standard deviation of the function are 0 and 1 respectively. If you observe the bell curve, which is here, normal distribution, on the x-axis there is a mu in the middle. And I told that mu is mean and two values or three values equal on both the sides spread to be mean and standard deviation. This mathematical function has two parameters, the mean and the standard deviation. This probability method plays a crucial role in asset return calculation, risk management, and strategy decisions. The following figure shows the statistical probability function of the bell shape follows the empirical rule. Here again I have taken the same bell curve to show this example too. The possible outcomes of the function are given in terms of whole real number lying between minus infinity to plus infinity. The tail of the bell curve extends on both the sides. See, on the x-axis there is a mu and the tail extends both the sides. Without the limits, approximately 68% of all observations fall within plus and minus one standard deviation. About 95% of all observations fall within the positive, negative, two standard deviations. Nearly 99.7% of all observations fall within three standard deviations. The normal distribution formula here once again with all the labelings properly. F of x is equal to, f of x is normal, 1 by sigma root of 2 pi e, that is minus x minus mu whole square by sigma. F of x is normal probability. Function x is a random variable which we have taken to calculate its normal distribution. Mu is the mean of distribution. Sigma is the standard deviation of the distribution. Pi is 3.14. E is 2.7. Transformation Z. When comes to the comparative study of two or more samples, there arises a need for converting their values into z-scores. This is done when we are calculating it into statistics. The transformation formula for asserting the z-score and following the formula, where x is a random variable. Real life examples of normal distribution. Where is it used? It is used in rolling a dice. For fair rolling of a dice is a good example of normal distribution. In an experiment, it has found that a dice rolled is 100 times. Chances to get 1 are 15 to 18%. It is a good example for normal distribution. It is taken as. Next is tossing a coin. Flipping a coin is one of the oldest methods for settling disputes. We all have flipped a coin before a match or a game. The perceived fairness in flipping a coin lies in fact it has equal chances of coming up. See, flipping a coin, there are only two outcomes, heads and tails, that is half and half. When we add both, it equals to 1. To calculate blood pressure generally follows a Gaussian distribution. In the general population, it makes Gaussian mixture models a suitable candidate for modeling blood pressure behavior. And applications of normal distribution also have in the mathematical aspect. It has fields of study, whether it has science, economics, statistics, finance, business, investments, psychology, health, genetics, biotech, or academics. Some of the typical applications are discussed below. The stock market of technical chart is often a bell curve, allowing analysts and investors to make statistical inferences about stocks, expected return, and risk. It is used in determining pizza companies when it is the best time to deliver pizza, and it is also applied in the business operations to determine efficiency of products and resources. They are used in determining the average academic performance of students. This mathematical function is used in determining the rank of a student. Thank you for knowing the knowledge of normal distribution.